Hi everybody and welcome to day 1. Today I'm going to be going over our first supervised learning model, linear regression. Alright, so what is linear regression? Well, linear regression is a model that tries to predict some continuous value given some data. So in this instance, it's trying to predict grumpiness level based on your sleep. Alright, and so ideally our model will end up looking something like this, where it best fits the data. So how do you create this line? Well, you're going to start off with some data, a training set, and it'll have features also known as X or targets also known as Y and also sometimes known as the output. Alright, so how does this work? We're given a formula, FWB of X is equal to WX plus B, which is very similar to the Y equals MX plus B formula, except that we have W and B as the parameters now. And this W and B optimize our model. It can take it from being inconsistent to great. But how do we choose the values of W and B that make our model great? Well, we have the cost function for that. What the cost function does is measure the error or loss for each point along our model. So it's the sum of all these, where y hat is the predicted value and y here is the actual value. Alright, so we want to minimize the cost, so our model looks something like this, where it crosses through all the data points. But how do we actually do that? Well, we want to choose a W that minimizes the actual cost function that's modeled here. Let's say if we were to pick 2, we might have a model that looks something like this, which is not going to help us in predictions at all. We want to get W to be at the minimum here. I kind of lied when I said that the cost function was going to help us find a good W and B value. What we really need is gradient descent. So the way this works is that we will use this formula to update W and B, and then that will in turn update our cost function or minimize our cost function to the best possible value. And so the way these formulas work is that W is updated with the learning rate times the derivative of the cost function with respect to W, and the same thing happens for B here. Be careful to note these are actual code implementations and not mathematical equivalences. So when we update this or write this out in code, we would write temp W is equal to this formula, same thing for temp B, and then actually update the actual values of W and B. If you were to implement it in this way, where you updated W and then updated B, your actual cost function would be incorrect. So what gradient descent is trying to achieve is convergence. That's when we find the W value that minimizes the cost function. And then from that, we should end up with a model that looks something like this against our data. One thing to note is a learning rate is pretty important. If your learning rate is too big, you could end up with a model that never reaches convergence and just ends up bouncing around. You want to be balanced in how you pick learning rate so that it eventually and steadily reaches the minimum. Alright, well that's the end of the lesson for today. I'm going to follow it up with some questions now. Here goes question 1. What are y and y hat also referred as? I'll give you a few seconds for that. Alright, so if you answered output and predicted or target and predicted, that is correct. Alright, question 2. I'll give you a few seconds for this one too. If you answered update parameter W by a small amount, that is correct. Alright, thank you guys for watching, and I'll see y'all for day 2.